Today we're going to talk about factoring some more, and we're going to look at a couple of what are called special forms today. And the special forms deal with some perfect squares. What's a perfect square?
It divides the square root of the whole number.
The square root is a whole number. So it's a number that there is some number times itself that will give us that. So if we start to try to list out our perfect squares, like 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because it's 2 times 2. 9 is 3 times 3. 16 is 4 times 4. 25 is 5 times 5. 36, 49, 64, 81, 100, 121, 144, 169, and that's as far as I can do. I think maybe 256 comes next. I don't know. But these are perfect squares. It's a number that there is some number times itself that will give us that number. A nice clean whole number times itself gives us this number. And perfect squares are going to be important to us today in our special patterns. The first one, we're going to have 2 perfect squares, and they're going to be subtracted. This is called a difference of squares. It only works with subtraction. It doesn't actually work with addition. And what we're going to do is we're going to take the square root of each of those things, and in our 2 parentheses, we're going to put the square root of the first thing in the front, the square root of the second thing in the back, and in one group we're going to use a plus, and in one group we're going to use a minus. Always, 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 no matter what kind of factoring we're doing, the very first thing you need to do is look to see if anything divides out of every term. So we look for 9 and 16. Does anything divide out of 9 and 16?
Yes.
3? 3 and 4, but the same number out of both of them? No. Okay, so there isn't a same number that divides out of both of them. Like they don't both divide by 2. Okay. So then we're going to look for this special form, which is a perfect square minus a perfect square. And this is that special form. So then the way this is going to factor is 2 parentheses, just like yesterday. In the front of each of them, we want to put what times itself is equal to 9x squared. So 3x would be 9x squared if we multiply it by itself. In the back of each group, we want to put what times itself will be the back number. So what times itself is 16? 4. And then we're going to do a plus in one group and a minus in the other group. We can check our answer from factoring if we FOIL it back the way that we learned to yesterday or distribute this out. If I multiply those first things, that gives me 9x squared, just like it's supposed to. If I multiply the last things, that gives me minus 16, just like it's supposed to. And what happens if I do my outers and inners? I get 12x and negative 12x, so they go away. And we would end up right back where we started. Right? So that's one way to kind of check your answers when you're doing a factoring problem. If you multiply it back out, you should end up right back where you started. All right, so is there anything that divides evenly into both 100 and 81?
No. 81. I didn't see 81.
Okay, so 100 divides by a lot of things. 81 is really only kind of divided by like 3 and 9. Those don't go into 100. So there's nothing to divide out. So we're going to set up our 2 sets of parentheses. What times itself would be 100x squared? 10x. What times itself would be 81? We do a plus and a minus.
That's it.
That's it for our first special form.
What do you mean when you say 3 is going to 100?
It doesn't divide evenly by 3. Like 100 divided by 3 is like 33 and a third. Alright, there's nothing that divides evenly into 64 and 25. 25 only divides by 5, and that doesn't go into 64. So there's nothing that divides evenly, so we set up our 2 groups. What times itself would be 64x squared? 8x. What times itself would be 25y squared? 5y. And we do a plus and a minus. Is there anything that divides evenly into both of these things? 2. So like yesterday, if that happens, we're going to put that number that divides evenly into them outside and then divide it out of them. Would leave x squared minus 4. Now we want to factor further, if possible. What times itself would be x squared? X times x, or 1x. What times itself would be 4? 2. And we do a plus and a minus. And that 2 that we took out at the very beginning still needs to be hanging out in front of the problem. A lot of times when students divide something out, it just disappears. It needs to keep on hanging out in the front of the problem. Questions? Yes?
Going back to number 3, like, what would happen if you were spoiling it back? What would happen, like, with the x times y?
Yep, so on this one, if we were checking our answer, there we go. We were checking our answer, we said it was 8x plus 5y and 8x minus 5y. So the first would give us the 64x squared, and the last would give us the minus 25y squared. If we do our outsides, I would get negative 40xy. We just kind of list them all out, multiply the numbers, but then list out all the letters. And then the insides would be plus 40xy. And since those are opposites, they just become a 0. Yeah, Rachel?
What did you divide for number 4 to get 2 x plus 2 x minus 2?
I started by dividing each number in the problem, the original problem, by 2. So that turned it into a 1 and a 4. And then we did our special form, guys, where we said x times x would be x squared, 2 times 2 would be 4, and then our plus and minus. So we're working only then from the last step. We don't go all the way back to the original. What divides out of 327? 3. So if I take a 3 outside, I divide each of the numbers in here by 3, and I get 100x squared minus 9y squared. That 3 keeps on hanging out, and we set up our 2 parentheses. What times itself would be 100x squared? And x. What times itself would be 9y squared? 3y. We do a plus and a minus.
So there always has to be like 2 sets of parentheses.
Yep, for the special form there will be 2 sets of parentheses, and they'll have the same numbers, but one will be plus and one will be minus. Okay? Our second special form is still going to be working with perfect squares, but it's going to have a perfect square in the front of it, a perfect square in the back of it, and then the middle thing is going to be double whatever those square roots are. It's a little bit harder to recognize, but we're still just going to look for those perfect squares at the beginning and the end of the problem and then see if the middle number works out. So always the first thing you do is make sure that nothing divides out of everything, and in this problem it doesn't. So then we check to see, is 4 a perfect square?
Yeah.
Yes. What is the square root of it? 2. Is 49 a perfect square? Yes, which is 7. If I multiply 2 times 7, I get 14, and if I double that, I get 28, and that should be your middle number. So that's how we check for this special form. Take the square roots of the first and the last thing, multiply them together, and then double it, and that should be your middle number. So we check for that special form and make sure that it is that thing first. Then, to factor it, we're only going to use one set of parentheses, and we're going to write it as squared. So this is kind of like a vertex form of factoring. In the front is going to go the square root of the front thing. And the back is going to go the square root of the back thing. The sign that we use is the sign of the middle thing. So in this problem we use a plus. Square root of the first thing, square root of the last thing, sign of the middle thing.
What if up top
Mm-hmm.
the square root of the first and last don't multiply?
Then it's not our special form and we can't factor it this way.
So it's not.
Yeah, it might still be possible, but not with any methods that you've learned so far.
Okay.
So yeah, then we would just say at this point, not possible, or not a special form. All right, so 9x squared. What is its perfect square? 3. 64. What is its perfect square? 8. Now we want to make sure this is a special form before we count this as our final answer. So if I multiply 3 times 8, I get 24, and if I double that, I get 48, which is our middle number. So that's what we need. We make the parentheses squared, and we use the sign of the middle number. So we're going to do a minus on this one.
Are the parentheses always squared?
Yep, for this special form, they will always be squared. (4x squared), what is its square root? 25, what is its square root? If I multiply 2 times 5, I get 10, and if I double it, I get 20, which is the middle number and what we need, and we take the sign of that middle number. What do you notice about all 3 of these numbers? They all divide by 2. So the very first thing that we would want to do is divide everything by a 2. Now we can check and see if what is left inside of there is a special form. What would be the square root of 9x squared? 3x. Square root of 49? If I multiply 3 times 7, I get 21. And if I double it, I get 42. Which is our middle number and what we need. And we take the sign of that middle number.
Would it have been the same if you had divided by 2?
It wouldn't be possible to do the special form if we didn't divide by 2 first, because 18 and 98 are not perfect squares. So we couldn't have used our special form then. What do all 3 of these divide by? 3. Divide a 3 out, and that leaves me with 4x squared, 10x, and 25. And then we'll try for a special form. What is the square root of 4x squared?
2.
What is the square root of 25? 5. If I multiply 2 times 5, I get 10. And if I double it, I get 20, which is not that middle number. So that special form doesn't work, and we just have to leave it there. Okay. So make sure you check for that special form. Just because that's the big idea of our lesson today does not mean every single problem we do is going to work that way. So make sure you actually confirm that it is a special form. Your homework is from 5.2 again, so it's the same page as last night, just different questions.